Assalamualaikum and good day everyone. My name is SHAHRUL ANUAR bin SUMIRIN. In this video, I would like to present about my final year project, which the title of my final year project is Automated Road Sign Recognition System, which supervised by Profesor MADYA Dr. Muhammad FAZLI bin FAUADI. In Malaysian autonomous car industry research, real-time video road sign detection and tracking are increasing rapidly. When real-time is combined with a road sign detection and tracking system, the system will detect and identify road sign. The road sign detection and tracking system is computerized system that recognize and detect road signs from video processing image. Most existing systems use image processing to detect and track road sign. This system will focus on developing an automated road sign recognition system by using artificial intelligence method, which is CNN, convolutional neural network, and camera will use as the main input in gathering relevant image. Problem statement. According to Kill and Majahan in 2016, they stated that it is difficult to track an object in an image sequence captured from a vehicle undergoing a generally non-uniform motion. Driver usually miss the road sign because of not giving fully attention when driving, which lead to miss the important road sign such as warning, prohibition, stop, and mandatory sign while driving on road. Problem statement second is the traffic sign can be divided into different categories depending on their colors and shape, such as red remote circular prohibition sign, triangular warning sign, and blue information sign, as stated by Zaklauta and Stan Silesu in 2012. Drivers often get confused with set of road signs such as circular, triangular, diamond, and rectangular. On the other hand, the colors of road sign which have few variation like red, yellow, blue, and green will usually confuse the driver. Problem statement 3 is lightning condition is a very difficult problem to regulate because it depends on the time of the day and also on the weather condition, as claimed by Swati and Nisha in 2015. This may cause the driver to unable to understand what mean by the road sign because they cannot see it clearly. Objective number 1 is to identify road sign by designing a real-time video road sign detection and recognition system by using image processing. Objective number 2 is to develop automated system that can classify 5 different type of road sign such as stop sign, no U-turn sign, direction sign, T-junction sign, and speed bump sign. Objective number 3 is to evaluate the effectiveness and improve the classification accuracy of road sign detection by using convolutional neural network. Scope number 1 is I will be focusing on the road sign using in Malaysia. The road sign detection and tracking is based on the color and shape. The color that will be detected is red, yellow, and blue, while the shape is circle, diamond, and triangle. The second scope is the distance of the camera capturing the road sign, which is fixed in the middle of dashboard, is taken from the distance of 3 to 6 meter between the camera and car. The video is recorded with the speed below 60 km per hour. Scope number 3 is HA, cascade, and convolutional neural network is the method used for road sign detection and classification. For literature review, Budiga and others in 2016 found a potential problem when driver want to recognize some road signs. The potential problem stated in the picture above, which is color fading, disorientation, occlusion, motion blur, low illumination, and high illumination on traffic sign. Many method and application is implemented by a previous researcher, such as J. Greenhart and M. Mir Mehdi in 2012, using a MSER, HOG, and RS, and as a result, they get a 85% accuracy. MSER detect high contrast region, but in their application, they have a time delaying. In 2012, F. Zaklauta and B. Stansius using a SVM, HOG, and RF in their application, and as a result, they get a 97% accuracy, and SVM's classification is fast and high accuracy. A. Gonzalez, L. Bagasa, and Jayabas in 2014 using a MSER, SVM, BOVW, and knife bias classifier in their recognition system, and as a result, they get a detection about 90.18% and recognition 87.5%. In 2015, J. Greenhart and M. Mirmehdi once again use MSER, SVM and OCR, and they get a detection 90.15%, recognition 87.5%, and HDB can be used to detect traffic sign better. Meanwhile, in 2014, Min Zhang, Hua Weiliang and Ziling using a color segmentation, counter detection, SVM and HOG for their detection system, and they gain a 93% accuracy. In 2015, KH Tauhidul Islam and Gopal Raj using a hybrid color segmentation and robust custom feather artificial neural network, and they get a high accuracy which is 99.9%. For Yang, Hua Weiliang and Fong Xiu Wu in 2016, they use a MSER, SVM and HOG, and they get a 98.24% accuracy. As a conclusion, this part explains about a few types of technique related to recognition and classification system. Several methods have been chosen, which is HA cascade for detection process and convolutional neural network for classification and recognition process. Methodology is explained about my experimental plan for my final year project. So from the start, the next process is development of road sign detection algorithm. The next process is development of road sign identification system. When these two processes is complete, I already achieved my objective 1. The next process is shape preprocessing and color space conversion, which is this process occurs in same times. The next is shape and color detection. Next process is development of detection algorithm. The next process is to detect whether 5 type of road sign that I mentioned in objective 2 is achieved or not, and if is achieved, I already achieved my objective 2. The next process is evaluation and classification. After that, I will evaluate whether my system accuracy is higher than 98% or not, and then if it achieve my 98% accuracy, my project will go to the end, which is achieve my objective 3. The distance and condition that I will mention in the next slide is the distance about 3 meter to 6 meter, and the condition have 4 conditions, which is daytime, nighttime, raining at daytime and raining at nighttime. For the step-by-step method, the first step is a coding is designed for detection and recognition process in Python. The next step is image of dataset is trained using HA cascade classifier for detection process and convolutional neural network for recognition process. Next step is webcam is fixed in the middle of dashboard of a car and connected with a personal computer. Next step is trained files is loaded in Python application and run while the car moving in speed below 60 km/h. The experimental is repeated 5 times for each type road sign to obtain the result. The equipment that I use for my final year project is camera webcam, which is used to detect any image of traffic sign on a road, and a computer, which is laptop, used to display an output of a classification and recognition system that been captured by a webcam, and a certain software such as MATLAB and Python for programming. The expected result is first, achieve all the objective that I already stated. Second, achieve more than 98% of recognition accuracy. Third, can detect all 5 or more road sign on a road. And lastly, the accuracy is not less than 98% in all 4 conditions that I stated before. That's all for my final year project 1 presentation. Thank you.